Hello. In the last video in the Minesweeper series, we looked at solving the board using brute force, and we also discussed whether or not we can improve this by calculating some probabilities. So this is actually my second attempt at recording the video. It didn't record very well last time, so this is the code we're going to end up with. We're going to include a button which actually calculates the probabilities for each square, and then it's going to use that data to actually go ahead and solve it. So let's do that now. So I think what we need to do is roll back to where we were. Oops. Okay, so we're back to where we were. Which is just like that, with a button to brute force it. So what we're going to do, first of all, is just display the probabilities. And I expect that's as far as we're going to get in this video. And then the following video, we'll be able to use that to actually improve our brute force. So to help debugging, yeah, we're going to add a button to calculate them. So let's do that first of all. Yep. So that's our new calculate button. And we need to wire up a on-click event. Oops, do that. Okay, so that should have added our button, and then when we click the button, we're going to just add, so update our drawer to say display probabilities. I'm about to spell this wrong at some point. And the way we're going to do this is we need to draw in each square, so we need to first of all move our origin to get to the edge of the board, and then loop through each cell. And we only want to display the probability if that cell is an unknown value, so if it's blank in this case. So we will calculate the probability, but for the moment we're just hard code it. And then we're going to draw the string in the cell, so we can do our draw string method. Okay, so the thing we're going to draw is the probability itself. We're going to need a quite a small font, so we can probably copy that one. So for the color, we're already using blue and red, so let's use green. And then finally, whereabouts we're going to draw it. So we want to draw it in the top left of the cell, so that's quite easy. That's just going to be column times cell size, and Y, same idea, but row times cell size. And we'll just make sure that's working. Okay, are we clearing the board and we don't need to? Yes. Okay, that's looking good. So next thing is to actually calculate the probabilities for each cell. So what we're going to return is, so we're going to return a value between 0 and 1. So 0 means cannot contain a mine. 1 means must contain a mine. And then 0.5 means we don't know. And then obviously we've got various values between the two. And the way we can calculate this is when we look at the neighbours of a cell, and if it contains a mine count, we then say how many mines that cell got left to find and how many empty spaces. So if one of our neighbours has a mine count of 5 and has 4 empty spaces, has a remaining mine count of 3 and there's 4 empty spaces available, then the chance of any of those cells containing a mine is 3 divided by 4. If we have 2 neighbours which contain mine counts, then it'd be the average of those 2 probabilities. So then there's a couple of exceptions. That if one of our neighbours has 2 mines left to place and there's 2 empty cells, then the probability is 1, and so we don't need to look at anybody else. So the first thing we need to do is find all our neighbours. So a lot of this code is actually similar to this method. Right, okay, so I'll copy that, might need that in a minute. So let's find our neighbours first. So that's all our neighbours, and then for each of those neighbours, we now want to see whether that neighbour contains a mine count, which is that code there. And then if it does contain a mine count, so our neighbour does contain a mine count, then we find how many of its neighbours have already been populated. And then we find how many of its neighbours are still unknown. Yep. And then we can then calculate how many mines are left to place. So if we have no mines left to place, then we know for a fact that the probability of this cell containing a mine is 0 because one of our neighbours can't have any more mines around it. So we can definitely exit early at this point. So the number of mines left to place, and we can just return 0. So the other one is if the number of mines left to place equals the number of which are unknown. And we know that can't be, so we're saying if there's no mines left to place, then it definitely can't contain a 0. If the number of mines left to place is the same as the number of unknown neighbours, that must be a 1. And we know that can't be 0 because we already checked that, so that's fine. So otherwise, we can work out the probability. So the probability is the number of mines left to place divided by the number of neighbours which are unknown. only we want that to come out as a decimal. And we also need to allow for a division by 0 problem. So if we don't have any neighbours, can that ever happen? I'm just trying to work out whether this can ever be 0. So if one of our neighbours, if the cell's neighbours is unknown, yet if all the neighbours are known, then there can't be any mines left to place. So I don't think that can ever be 0. Okay. So the next thing is we need to handle the case that we might have to average 2 mine counts from 2 different neighbours. So we actually want to have we want like a total probability up here, which actually we're going to add 2, and that's the thing we're going to return at the, well, and because it's going to, we want to be an average, we also need to count the number as well. So at the end we're going to return total divided by the number, and we probably want to round that. We'll try that now, yes. Oh, I did get a division. Oh, okay, so in this case we didn't have any neighbours. Oh, we did. So none of the neighbours had mine counts. Okay, well, if none of the neighbours have got any mine counts, then we just want to return 0.5 because we've got no idea. I'm surprised that happened though on the first cell. Because that first cell does have 2 neighbours with mine counts. Right, so what have we done wrong here then? Let's put a breakpoint in. So 0, 0, so we've got 3 neighbours, 1, 2, 3. So our first neighbour is column 1, row 0. Ah, yes, that's the problem. I fixed these, but I didn't change that one. So I was looking for the mine count in the wrong cell. Right, let's have a look at some of these then. So this cell here contains 0, so none of those can contain mines, which is fine. This cell here can only be affected by this one, and this one's got 1, 2, 3, 4, 5. So it's got 2/5, which is 0.4. This one, however, it's got the average of 0.4 and 1, 2, 3, 4, 5. The average 0.4 and 0. Sorry, the average of 0.4 and 0.2. So we're saying that's less likely. A cat. So I think that's correct as well, because that does come to 0.3. So that's good. So next time, in the next video, we'll use that to actually drive the decisions we make when we're brute forcing it. Thank you.